Hello everybody, this lesson is for factoring quadratic trinomials. Just a review of what we've learned so far about factoring. We can factor by factoring out the greatest common monomial factor, so finding what's in common between the different terms with the coefficients and with the variables and exponents. We've also factored out perfect square trinomials, where the first term is a perfect square, the last term is a perfect square, and this middle term is found by multiplying 2 times the square root of this, so 4x, times the square root of this, so times 3. Just to double check, 2 times 3 is 6. 6 times 4x, you get 24x. And we've also talked about difference of squares pattern, where you're subtracting two perfect squares, the two different binomial terms, binomial factors, square root of this first term, so 5x and 5x, square root of this last term, so 6 and 6, and they're always separated. One is subtraction, the other is addition, so that middle term cancels out. For just factoring a trinomial that doesn't have a specific pattern, it helps to think of it as working backwards from the FOIL method. So just keep that in mind as you're working. If we have two binomials and we want to multiply them, we're thinking of multiplying using the FOIL method. So the first times the first to get your first term. The outside two terms to get your next term. Inside two terms, you get 3x, and then the last two terms, you get 6. And then those two middle terms add up to be 5x then. So think of this process for multiplying using the FOIL method when you're given the trinomial to start off with and you have to find the two binomial factors. So what you're trying to do is look at this last term. You want to think of the different ways, the different factors that you can multiply to get to 36 that when added equal 13. So first think of listing out the factors. So for 36, obviously you could have 1 and 36. You could have 3 and 12. You could have 4 and 9. You could even have 6 and 6. So now looking at this, if we were to now add these different factors, I need to find the one that when added equals 13x. So 1 plus 36, if I add those two, that's 37. That one didn't work out. 3 and 12, if I add those, that equals 15. 4 and 9, there's 13. Last one, 6 and 6 is 12. This one here added up to 13. So then the two binomial factors, one would be x plus 4. The other would be x plus 9. And you always want to get in the habit of checking to make sure you did it right. So if we multiply these back through using the FOIL method, x times x is x squared. X times 9 is 9x. X times 4 is 4x. And then 4 times 9 is 36. Simplifying, you end up with x squared plus 13x plus 36. And that matches our original trinomial. Looking at another example here, looking at this last term again, listing the factors. Now this one is a negative number, so we could have more possible combinations. You could multiply a negative 1 and a positive 6. Another option could be that same pattern, a positive 1 and a negative 6. You could also multiply 2 and a negative 3, or a negative 2 and a positive 3. So all of these different combinations, when I multiply them, will equal a negative 6. So the next step, which ones add to equal a positive 5? Negative 1 plus 6, that one actually equals a positive 5. But just double check the other ones. 1 and a negative 6, that would be a negative 5. 2 and a negative 3, that would be a negative 1. Negative 2 and 3, that would be a positive 1. So this is the one we wanted that added to equal 5. So then our two binomials, how this would factor, is x minus 1 and x plus 6. And then always double check by going back and foiling it. So x times x is x squared plus 6x minus 1x when you multiply, and then a minus 6, and that will give you a positive 5x. One last example here. Since this one equals a negative number, again, you're listing out negative terms, but we want the ones that when added equal a negative 36. So looking at these, we kind of already listed out for 36 before, but we could have a negative 4 and 9. If I add those two together, that's going to equal a positive 5, so I know it's not going to equal that one. Even if I flipped it around to be a positive 4 and a negative 9, well, then it would equal a negative 5. If I did a positive 3 and a negative 12, negative 12 plus 3, that would equal a negative 9. If I did negative 3 and 12, that would equal a positive 9 when adding. If I did a negative 6 and a positive 6, that would equal 0 if I added them. I could also do a negative 2 and a positive 14. That would equal 12. Even if I did a positive 2 and a negative 14, that would equal a negative 12. If I did, oh, this one here actually should be 18. 2 and 18, not 14. So a negative 2 and a positive 18, this would equal a positive 16. So we're close. Then this one, a 2 times a negative 18. When I add those two equal a negative 16. So this one would factor as x minus 18, x plus 2. And the order of those terms doesn't matter. If you flip-flop them as x plus 2 and x minus 18, flip-flopped around, it'll still work out to be the same answer. But definitely get into the habit of checking using your FOIL method. So x times x is x squared, x times 2 is 2x, negative 18 times x is a negative 18x or minus 18x, and then negative 18 times 2 would be minus 36. And then adding them together, you end up with your x squared minus 16x minus 36.